Expecting you put it where the sun is, it would loosen up to the circle of Jupiter. A beast, absolutely precarious and going to detonate. They are among the most detectable effects of radio energy in the whole universe, conveying more energy than a billion suns. Uigu, or the surprising Crawley-Ju, is a red giant star. Excepting you put it where the sun is, it would interface with the circle of Jupiter, tremendous, totally conflicting, and, in addition, going to detonate. When we contemplate stars, we no doubt envision unessential, witnessing things in the night sky. Essentially, this is the way we see them from down here on the planet, yet stars are something else entirely. Truly, perhaps, quite possibly, one of the most conspicuous stars, Betelgeuse, is generally more significant than our sun. For a really long time, this star has baffled generations. In any case, honestly, something extra disturbing has been occurring with Betelgeuse, making reviewers and other exceptionally accomplished people phenomenally concerned. Oblige us in this video as we examine the terrific new information about Betelgeuse, its coming destruction, precisely true to form by the James Webb Space Telescope, and what this new headway will mean for our universe and our lives here on Earth. As explained by physicist Michio Kaku, Betelgeuse is a huge wonder, a monster star that has captivated cosmologists for such a long time. A Greek space master named Antonius was the first to track it down. This star is massive to the point that it can be seen in the night sky from Earth, especially during winter. If you're into cosmology, you've undoubtedly seen or heard about this star. The becoming flushed orange star marks the upper left shoulder of the Orion constellation. So, you see, this star is ancient and, hitherto, perhaps one of the most magnificent stars in the night sky. Yet, one thing about Betelgeuse's brilliance is that it doesn't remain trustworthy. Rather, it varies. This change is one of the great properties of the star, but it isn't the only one. We should investigate some of Betelgeuse's particular properties. Most of the stars you see in the night sky are far from Earth. The closest star is 4.2 light-years away. If you consider how the term light-year gives a sense of distance, picture it this way. Imagine moving at the speed of light for an entire year. It's been proven that light can cover a distance of 186,000 miles per second. Hence, the distance light can cover in a year is essentially equivalent to 1 light-year. If you do the math, you'll get billions of miles. So when we say the nearest star is 4.2 light-years away, it means it is still billions of miles from Earth. Some stars are even farther away, and Betelgeuse is one of them. Betelgeuse is found around 600 light-years from Earth. So, expecting that you somehow ended up traveling to it at the speed of light, it would still take 600 years. We can't move that fast. Not even our speediest space rockets can. However, this star can still shine so brightly in our sky. If you're wondering how Betelgeuse can be so extraordinary despite its distance, it's because of its remarkable characteristics, like size and quality. Betelgeuse is many times more massive than our Sun. Its radius is perceived to be regularly larger than that of the Sun. Unfortunately, it appears as a disk in space when using current telescopes, whereas other stars appear as small spots of light. This is believed to be an effect of the reactions on the outer layers of its atmosphere. Regarding mass, Betelgeuse weighs around 12 to 19 solar masses. A solar mass is the standard unit of mass used by space analysts. One solar mass is equivalent to 2 times 10 superscript 3 kg. Experts can't determine the exact mass of Betelgeuse since there are no planetary bodies orbiting it to compare against, and we can't measure it directly from Earth. However, Betelgeuse is estimated to be many times heavier than our Sun. The brightness of Betelgeuse ranges from magnitude +0 to +1.6. In simpler terms, Betelgeuse is generally brighter than our Sun. No wonder it was nicknamed a red giant. However, the nature of Betelgeuse doesn't remain stable. It varies. This change is due to its pulsations. In other words, Betelgeuse expands and contracts. When it expands, it gets brighter, and when it contracts, it dims. This cycle can last for 10 to 100 days or even longer. A fascinating property of Betelgeuse is that its surface is covered in dark magnetic spots. The magnetic field here is significantly stronger than at the typical surface. However, the downside is that these strong magnetic spots slow down the movement of hot gas to the star's outer surface, making the star cooler. Despite its size and brilliance, The Sun also has its own dark magnetic spots. However, those on Betelgeuse are significantly larger and more numerous. To give you an idea, the spots on Betelgeuse can be twice as wide as Earth. Betelgeuse exhibits a magnetic field that is thousands of times stronger than that of the Sun. This field explains why, when seen through a telescope, the gases on the outer layer of Betelgeuse appear to be swirling or spiraling. Betelgeuse has a surface temperature of around 3,500 K. This low temperature contributes to the low energy released by the star and its dim red color. Betelgeuse is a red star, but it wasn't always red. It was yellowish about 1 million years ago, similar to our Sun. Over time, its color began changing to orange-red, and then, around 40,000 years ago, it gradually turned into the red star we know today. This fact has led scientists to believe that the star is aging. Betelgeuse produces as much as 100,000 times more energy than the Sun. If it weren't so far away, it would have been a strong competitor to Earth's Sun. The fact that Betelgeuse, which is 600 light-years away, can still be seen and recognized with the naked eye at night is incredibly striking. Our Sun is only 8.3 light-minutes from Earth. That's why it appears so strong. If Betelgeuse were slightly closer, we would also be able to see it during the daytime. However, if it somehow replaced the Sun, it would engulf or displace Earth and the other 4 inner planets due to its massive size. Moreover, even if it matched the Sun in size, it would still emit more radiation. Betelgeuse, also known as Betelgeuse, is a very massive star located in the Orion constellation, around 600 light-years from Earth. Gigantic size is possibly one of its most striking parts. Betelgeuse is customarily more critical than our Sun concerning its size and could undoubtedly encompass the orbit of Jupiter if placed at the center of our solar system. This unfathomable size allows Betelgeuse to appear as a disk rather than a point of light when viewed through strong telescopes, unlike most other stars. Despite its enormous size, Betelgeuse is not the largest star. Its mass ranges from around 12 to 20 times that of the Sun. This variation in mass estimates is due to the challenges in accurately measuring the mass of stars that lack companion stars or other objects to provide gravitational reference points. Even at its lower estimated mass, Betelgeuse remains a giant celestial body. Brightness and variability. The brightness of Betelgeuse is another key characteristic. It fluctuates over time, with its magnitude ranging from 0 to plus 1.6. For comparison, a magnitude 0 star is about 2.5 times brighter than a magnitude plus 1 star. At its brightest, Betelgeuse can be several times more luminous than our Sun. This variation is attributed to its pulsations, irregular expansions and contractions caused by internal cycles within the star. When Betelgeuse expands, it becomes brighter. When it contracts, it dims. These pulsations can last for years, contributing to its dynamic appearance in the night sky. Temperature and evolution. Betelgeuse's surface temperature is relatively low for such a massive star, measuring around 3,500 Kelvin. This gives it a distinct red tint, characteristic of red giant stars nearing the end of their life cycles. Like other red giants, Betelgeuse is in the late stages of stellar evolution. It has exhausted the hydrogen fuel in its core and has begun fusing heavier elements. This fusion process generates energy and causes the star to expand outward. The star's atmosphere is rich in complex physical phenomena, displaying dark magnetic spots where the magnetic field is stronger than the surrounding areas. These spots prevent the convection of heat, leading to cooler regions on the surface. Despite these cooler spots, Betelgeuse remains an exceptionally bright star. However, it will eventually meet its end in a spectacular, catastrophic explosion. The eventual supernova. Betelgeuse is a massive star nearing the end of its life, and its eventual fate will be dramatic. When it runs out of fuel, it will undergo an extreme process of fusion, forming heavier elements like helium and carbon. This will cause the star to expand even further, making it one of the largest stars in the night sky before it dies in a massive explosion. A supernova of this magnitude releases more energy in a short time than our Sun will produce in its entire lifetime. This kind of stellar death leaves behind a remnant that could either be a neutron star or a black hole. Despite its impending explosion, the effects will not be felt on Earth for thousands of years. Even though Betelgeuse is relatively close in cosmic terms, its distance of approximately 600 light-years means that any effects from its death, including the explosion and radiation emission, will take centuries to reach us. The final stages. As Betelgeuse approaches the end of its life, it will enter a crucial phase known as the supergiant stage. During this time, it will continue to burn through heavier elements in its core. As the fusion process advances, it will produce increasingly complex elements such as carbon, oxygen, and eventually iron. Once Betelgeuse begins fusing iron, it will have reached the limit of its ability to generate energy. At this point, the core collapse will begin, leading to a colossal event known as a supernova. In its final stages, Betelgeuse will undergo violent oscillations, expanding and contracting with extreme intensity. These fluctuations will cause the star to shed its outer layers in explosive eruptions, creating a cloud of gas and dust. These materials will be ejected into space, enriching the surrounding cosmic environment with the elements necessary for the formation of new stars, planets, and even life. This process of mass ejection can last thousands of years, but eventually, the core will collapse inward due to gravity, triggering a supernova. The supernova impact. The supernova itself will be a dramatic release of energy, outshining the entire galaxy for a brief period. It will unleash an immense amount of radiation and particles, which could affect nearby star systems. However, due to its considerable distance of 600 light-years, this radiation will not significantly impact Earth. It is important to note that while Betelgeuse's eventual explosion will be breathtaking, it is far enough away that it will not pose a direct threat to our planet. However, it may alter the structure of the Orion constellation. The aftermath. After the explosion, Betelgeuse's remnants will either become a neutron star or a black hole. If the core's mass is large enough, it could collapse into a black hole, an object with such immense gravity that not even light can escape it. On the other hand, if the core is not massive enough to become a black hole, it will form a neutron star, an incredibly dense object made primarily of neutrons. Astronomical significance. The eventual destruction of Betelgeuse will be of immense significance to astronomers and astrophysicists studying stellar evolution. This event will provide valuable insights into the life cycles of massive stars and their impact on the universe. However, for humanity, it is unlikely that we will witness this event firsthand. With Betelgeuse's explosion still thousands to millions of years away, it remains a subject of distant cosmic curiosity rather than an imminent spectacle. Nevertheless, Betelgeuse's death will have a lasting impact on the structure of the Milky Way. As the supernova ejects its materials into space, it will contribute to the formation of new stars and planetary systems, enriching the galaxy with heavier elements. The explosion may even trigger the formation of new stellar nurseries in the surrounding molecular clouds. Conclusion. The remnants of this colossal star will continue to fuel the cycle of life and death in the universe, ensuring that the cosmic process of stellar birth and death continues uninterrupted. Thus, while we may not immediately experience the effects of Betelgeuse's demise, its eventual supernova will leave a lasting mark on the history of the universe. It will serve as a reminder of the immense forces at play in the cosmos and the fleeting nature of even the largest stars. Betelgeuse's death will be one of the many celestial events that shape the universe as we know it, paving the way for the birth of new stars, planets, and possibly life itself. The aftermath of Betelgeuse's supernova. Once Betelgeuse explodes in a supernova, the impact will be felt across its local region in space. The shock wave from the explosion will send high-energy particles and radiation through the interstellar medium, interacting with nearby dust clouds and potentially triggering the formation of new stars. This means that while Betelgeuse will die, its destruction will play a key role in the rebirth of other celestial bodies. This is a crucial part of the stellar life cycle. Massive stars explode, spreading essential elements such as carbon, oxygen, and iron across the universe, which later contribute to the formation of new planets, moons, and possibly even life. What happens to Betelgeuse's remains? The core of Betelgeuse will either 1. Form a neutron star. If the remaining mass is between 1.4 and 3 times the mass of the Sun, it will collapse into a neutron star, an incredibly dense object where a teaspoon of material would weigh billions of tons. Neutron stars rotate rapidly and can sometimes become pulsars, emitting intense beams of radiation. 2. Form a black hole. If the remaining core is massive enough, over 3 times the mass of the Sun, gravity will overwhelm all other forces, collapsing the core into a black hole, a region of space where gravity is so strong that nothing, not even light, can escape. The exact outcome depends on the mass of the core after the explosion, but given Betelgeuse's size, both possibilities are viable. How would we see Betelgeuse's supernova? Since Betelgeuse is only 600 light-years away, when it explodes, it will be one of the most spectacular celestial events in human history. Here's what would likely happen. The supernova would be visible in broad daylight. It could shine as bright as a full moon for weeks, possibly even months, before gradually fading. It would be one of the brightest objects in the night sky. The explosion would be visible to the naked eye without telescopes. Astronomers would be able to study it in real time. This would be the first supernova explosion of a nearby star observed with modern scientific instruments, providing valuable data on the nature of stellar death. Could Betelgeuse's supernova impact Earth? While the explosion will be incredibly bright, it will not pose a threat to Earth. At 600 light-years away, Betelgeuse is far enough that its radiation and shockwaves will not cause significant damage to our planet. The only potential effect might be a slight increase in cosmic rays reaching Earth's atmosphere, but this would be minor compared to other cosmic radiation sources. The long-term impact on the Orion constellation. Betelgeuse is one of the most recognizable stars in the night sky, marking the shoulder of Orion in the Orion constellation. Once it explodes, the Orion constellation will change shape. Future generations will see Orion differently, as Betelgeuse will no longer be visible. The region around Orion may develop a new nebula. The ejected materials from the explosion could form a beautiful nebula, similar to the Crab Nebula, which was formed by a supernova recorded in 1054 AD. The cosmic legacy of Betelgeuse. Even after its death, Betelgeuse's influence will continue. Its elements will seed new stars and planets. The materials released in the supernova will spread across space, enriching the next generation of celestial objects. Its explosion will provide valuable scientific data. Observing a nearby supernova in real time will help scientists understand the evolution of massive stars. Its fate reminds us of the universe's ever-changing nature. The universe is constantly evolving, with stars being born and dying in an endless cycle.